Opa! Olá, pessoal. Boa noite. Sejam todos bem-vindos a mais um meetup do Brasília Elastic User Group. Muito obrigado pela presença aí. Aqui quem vos fala meu nome é Adam, nós somos os que auxiliam na organização da comunidade aqui em Brasília. E a gente está aproveitando esse momento de pandemia, de isolamento, que a gente não pode fazer nossos meetups presenciais, que são o que a gente mais gosta, para fazer alguns eventos online. E já que são online, estamos convidando pessoas de de lugares mais distantes. Hoje, por exemplo, convidei um antigo colega, Julio Camarero, que hoje é engenheiro na Elastic, e ele trabalha com a Elastic Cloud produzindo trabalhando com Cross Cluster Replication, Cross Cluster Search. Então, hoje ele vai me apresentar um pouco desse conteúdo, que é uma coisa que me perguntam muito, e vai ser interessante. E eu mesmo tenho que aprender mais. Tem sido uma coisa em aberto no meu conhecimento, embora lá no trabalho a gente use bastante isso na live. A apresentação vai ser em inglês, porque o Julio é espanhol, na verdade ele está nos fazendo um grande favor, ficando acordado até tarde, para apresentar num horário conveniente para nós. Então a apresentação vai ser em inglês, mas qualquer dúvida que vocês tenham, pode escrever no chat, mesmo em português, que a gente vai tentar responder posteriormente. Para aqueles que provavelmente não... Como eu sei que geralmente o pessoal que faz a apresentação convida colegas conhecidos para apresentar, eu também vou falar em inglês da agora em diante, assim eles podem participar também. Se qualquer pessoa, as pessoas não se sentirem tão perdidas com um cara falando português o tempo todo. Enfim, deixe-me apresentá-los. Let me present you, Julio Camarero. Hello, Julio.
Hello, Adam. How are you?
I'm good, and you?
Very good. Hello, everyone.
I have to thank Julio for taking not only their effort of build the presentation to us, but also to stay late at night, because it's 11:30 in Madrid right now. So he is doing a bit of a sacrifice to present out his knowledge to all of us. Julio, as I commented before, is an engineer at Elastic. He works with Elastic Cloud, setting up, making cross-cluster replication and cross-cluster search work on Elastic Cloud. That's right, Julio?
Yes, that's right.
Perfect. So now I will leave the presentation to Julio, and at the end I will come back. Please, everybody, have a good time learning a bit, as I will be doing here as well. It's up to you, Julio.
Okay, thank you very much, Adam. So welcome everyone to this talk about this multi-cluster architecture. So it's the first time I give this talk. I just prepared it for today, so I hope it goes well. I wanted to start with a very brief introduction about Elastic. For those who you all probably know, but Elastic is a search company, and usually when we think about search, we think about the search box on an app or a website, but it's much more than that. Elastic, for example, can be search can be used to find the closer Uber driver when you want to go somewhere, to find a perfect match on Tinder, or to find a song that your friends like in Spotify. And all those examples are powered by Elasticsearch, for example. And even though search was the foundation, and it's the main goal of Elasticsearch is to build an open source search engine that delivers fast and relevant results, we've seen our community use it for many different use cases, and they can be mainly classified in these three groups, mainly search, observe, and protect. So search is for creating very dynamic, powerful search experiences for apps and websites. Observe is mainly for observability, to monitor your systems, your applications, logs, metrics, everything, performance. And protect is about threats, about detecting threats, keeping all your systems secure, and even all the systems in your organization, and even all your users. So those are the different use cases we've seen Elasticsearch is being used for. And we provide actually these three solutions powered by the Elastic Stack that can be deployed anywhere. We have Elastic Enterprise Search, used to build very powerful search experiences for apps and websites. elastic observability for monitoring, logs, APM, metrics, and elastic security for detecting threats and solving security issues in your systems, organization, and anything else. All these solutions are powered by one stack, by the Elastic Stack, which the core, the heart is Elasticsearch. Then we have Kibana for the visualization, and usually bits and logstats for ingesting information into the search engine, right? And this can be deployed anywhere. So we have Elastic Cloud. I will be using Elastic Cloud for my demo tonight. We also have Elastic Cloud Enterprise, which is the same tool we use for orchestrating Elastic Cloud, but on-premise. And also we have Elastic Cloud on Kubernetes for orchestrating all your Elasticsearch clusters using Kubernetes. So that's enough of introduction. I wanted to start talking about a cluster. Usually when we talk about an installation of Elasticsearch, we always talk about an Elasticsearch cluster because you want to grow your data, and Elasticsearch clusters can grow to hold as much data as you want to put there. And actually, you can have different nodes that can specialize to serve different roles in the cluster. And then that way you can use the most appropriate hardware for each of the roles, for example. And most people start with one cluster for one organization, right? But at some point, many situations, many scenarios start having more than one cluster. And I will go through those use cases today. And then Elasticsearch provides some tools to help you manage all that. Let me start with some of these use cases we have for multiple clusters. One very common use case is the multi-tenant app, which is when you have one cluster for a group of customers, or maybe one cluster per customer, another cluster for another customer. And sometimes this is very common because you want to isolate the loads of these customers and you don't want a noisy neighbor to affect the other customers, for example. Another common scenario is the one cluster per application. You have different applications in your organization, and then you want them also to isolate the different Elasticsearch clusters and maybe also scale dependently with the app and not have dependencies between each other, because you may want to have one app in maintenance, for example, or the others working up, doing upgrades, and you don't want to have one applications affecting the others. Other scenario is one cluster per geography, usually one cluster per region, maybe, or per data center. There are many reasons for that, and I'll go into that later. Another example is disaster recovery and high availability. So you have more than one cluster. In case one of them goes down, you still have the others. And also centralized reporting. For example, you have many clusters around the world, and then you have one cluster which is able to have visualizations and reports on all the other clusters. And also, for example, another example is upgrades. When you have time-based indices, for example, you may want to start using a newer version of Elasticsearch. What you can do is have the old one and also the new one, and start indexing the new information in the new one. And the old one probably has data which becomes less relevant with time, and at some point you can just stop using that one. So it helps you do the migration. And also a combination of all these above. There are many different combinations, many different scenarios for having multiple clusters of Elasticsearch. And the thing is, right now you can start creating one Elasticsearch cluster here, another one, another one, another one. Nothing prevents you from doing multiple Elasticsearch clusters, and there's nothing magic there. But the cool thing I want to talk today is about several mechanisms that Elasticsearch provides to help you with these multiple clusters, because you will usually need some kind of communication between them or synchronization. So I'm going to talk about those today. The first of these tools is Cross Cluster Search. And the name is very self-explanatory. It allows you to search across multiple Elasticsearch clusters, right? Definition is here. Cross Cluster Search allows a query to run against indices in clusters geographically distributed. So let's go with this example. We have this data center one, which has one cluster with this index. And then we have this other data center, which has another cluster which contains a different index. And we can have yet another cluster, whatever. And this one is able to run a query against the data in these two indices, right? And it's not just one search here, because it actually can, for example, sort the results by relevance from the data in both indexes. So one of these scenarios, one simple one, is we have this tenant, this user in this cluster, for example. This is this multi-tenant app. Another tenant in another cluster, and so on. So one tenant per cluster. And then we have this another cluster, which we call the control cluster, which allows us to have a global view of clusters. So we are going to be using cross-cluster search here to search information around all of these, because sometimes you want to have some reports on usage or whatever information from all your tenants. And something very interesting, for example, in this cluster, in the control cluster, we are not storing any data. We are not doing any ingest. So we don't need, for example, ingest nodes, data nodes. We can just have master nodes here, because these are just going to be making queries to the other clusters. Very similar example is the sample cluster per region. So imagine we have one cluster in the US, another in Brazil, another in Spain, another in Japan, and then you still have this control cluster, which allows you to have a global view of all the others. And same situation, you only need master nodes here, because in this cluster, you are not storing information, you are not ingesting data, you are just querying all the other clusters all together. And I'm going to show you how this works. I have these two restaurants. This one is called Chuka Ramen. It's in Madrid. It's one of my favorite restaurants here. This one is in Recife. It's called Camarero. And I wanted to show you a little example I've been working on. So I'm creating, this is Elastic Cloud, and I've created a few clusters here, 4 clusters actually. And the first one I'm going to show you is this cluster, Restaurants Spain. I'm going to launch Kibana. And in this cluster, what I'm going to do is I'm going to have one index for restaurants, but restaurants in Spain only. And then I'm going to do the same thing for Brazil. And then we are going to do some cross-cluster search from those. So this is just a regular cluster, Elasticsearch. And I'm going to do some steps, but they are going to be very simple steps. Okay, here we are. So we have, I'm going to just cut, probably the DevTools is a tool just for making queries here very fast and simple. So I'm just going to cut all the indices. I have all the hidden indices from cluster, nothing fancy yet. So I'm going to create this index, which is called Restaurants Spain. And it's the typical index. I have some mappings for the email of the restaurant, the name, the description, the number of diners, food type, location, just regular mappings. Okay, so I'm going to create this index, which is empty for now. And then I'm going to add this restaurant I told you I love in Madrid, Chuka Ramen. So I'm going to just put this document in my index. You can see the location in Madrid, all just very common. So now I can run this query to search in my index, the Restaurants Spain index. And you can see I can find my one result, which is this restaurant, okay? So I'm going to do the same thing in another cluster here I just created, which is Restaurants Brazil. It's a different deployment, a different cluster. And I'm going to do the same thing. You see there's nothing here yet. I'm going to create an index with the same mappings, but this one is called Restaurants Brazil. It's not Restaurants Spain. So I'm going to create the index. And now I'm going to add this restaurant, Camarero. And now if I search for it, this is just a typical query, just match all the results. I get this restaurant, okay? So you can say I have one cluster for Restaurants Spain, one cluster for Restaurants Brazil. So now I'm going to create yet another cluster. I'm going to call it Restaurants in general with cross-cluster search. And this one is going to be a bit different because in this one, I'm going to configure the other two as remote clusters. And this, I've done it before, just to avoid copy and pasting. Creating a remote cluster is very simple. You just give it a name. And after giving it a name, you just need to configure here the IP address of your nodes. Or also in the most recent versions, you can use the proxy mode, which allows you to have just one proxy in front of all your nodes, and then you just need to have the domain of the proxy, and you don't need to know the IP of all your nodes. But that's how you configure it. It's so simple, name and then the IP address, right? So I have configured here for this cluster, the CCS, I have configured the Restaurants Brazil remote cluster and the Restaurants Spain remote cluster. This is the name of the remote cluster. So now what I can do in the DevTools, and as you can see in this cluster, I don't have anything regarding restaurants yet. What I do have is my remote clusters. You can see when I get the remote information, I can see I have the restaurants Spain and restaurants Brazil. This is the name of the alias I given to this remote cluster. This is not the name of the index. I actually use the same because otherwise I would forget. And here for the search, this is cross-cluster search. I can say, okay, search in this remote cluster called restaurants Spain, and search in this index called restaurants Spain. I know the same name. But this allows me from here, from this one, to search in Spain, for example. And also, I can do the same thing for Brazil. I can search the restaurants in Brazil, so I can find this one. But the real cool stuff is that I can mix both. So I can run one query against both of them. So I can say, search in restaurants in Spain, also restaurants in Brazil. But this is just one query. And for example, sort all the results by geodistance from where I am right now. This is my current location. So this is going to search in both of them and sort the results. So this is returning first one, the one in Madrid, because it's very close to me. And this one is much farther. So they are sorted in order. So it's just one query against all the indices in all my remote clusters. So back to the presentation. Well, if people have questions about cross-cluster search, I'm happy to answer now. I don't know if you have any question.
Well, I personally do have a question, if you can answer that. You say that the carried cluster, the cluster that is subordinated by other cluster, that is carried by the other cluster, does not need necessarily some kind of nodes. I mean, I could have or did I heard it wrong?
So in the cluster that you are doing cross-cluster search, you only need master nodes. You don't need data nodes or ingest nodes. You only need master nodes because you are only making queries to the others and just getting the results, aggregating it, and displaying it. But you are not storing information and you are not ingesting any data. So you don't need to ingest pipelines or anything like that.
That's perfect. So in this case, the cluster that carries the other cluster, that contacts the other clusters, is the one that doesn't need anything other than master node.
Exactly. So in these clusters, for example, this one in the US, you have master nodes, ingest nodes, data nodes, maybe hot nodes and warm nodes. You have all the nodes here. But this one, which is the cross-cluster search one, this one only needs master nodes because this one just makes queries to the others and then present the results. This one is not doing any storage and it's not doing any processing to store information.
Perfect then. So just to proceed with another question that arrived here, the master cluster can be quite small, so to say, in terms of resources, right?
Exactly. It can be very cheap hardware because you don't need a big hard drive. You don't need to have a lot of speed. So it can be very cheap hardware. It only makes the queries and just orchestrate the code. So it's you don't need very fancy hardware to do this.
Okay, perfect. That was very clear. That was very clarifying to me. Thank you so much. I guess there is no question right now on Cross Cluster Search.
Okay.
But people, if you have any questions about Cross Cluster Search later, just post it on the chat. We can come back later, right?
Perfect.
Okay,
Absolutely.
I'll give the word back to Julio.
Okay. So the other mechanism, which is very interesting, is cross-cluster replication. And this one, the other one was about searching in other clusters. This one is going to be about replicating the information that exists in other clusters. Definition is cross-cluster replication allows an index to be reliably and efficiently replicated between geographically distributed clusters. So in this example, we have this data center. In this data center, we have one cluster with one index, and then we have these two others. It could be any different number. we have other clusters which just hold a replica of the index, right? And the way this works is that these replicas are read-only. The leader is the only one which accepts writes. These ones are replicating the information from this one. And that means if you add information to this index, it gets added to the others. If you remove it, it gets deleted. Even if you change the mappings, that's also propagated to the other indices, for example. This is a pull mechanism. This is very important because that means the leader index, this one, is unaware of the followers. It can have as many as it wants, is unaware of them. And this replication process does not interfere with the indexing. So this is very important. This is part of the efficiency, which is performed at the some level. I'm going to go through some scenarios also that benefit from this mechanism as before. So let's say we have this high availability example. So we have data center 1 with one cluster, data center 2, another cluster, data center 3, another cluster, right? And then we have 3 indexes. But the cool thing is, in the cluster 1, it's going to be writing to this index A, which is going to be then replicated to the other 2 data centers. Cluster 2 is going to be writing to this leader index B, which is going to be replicated to the other 2. And the same in cluster 3. This leader index is going to be replicated to the others, right? So each data center only writes to one of them, but can read from the 3 of them. In the situation in which one of them data centers goes down for whatever reason, all the information is still available for reads in the other clusters. Another example for high availability. Let's say we have this production data center and a disaster recovery data center. So in the production data center, we have these 3 indexes, and our applications are writing and reading in those indices. But then we have a replica in other disaster recovery data center of all the indexes. So imagine the production data center goes down. All the information is still here, so we can switch our applications to read from this one. And we can even switch these indices to be the leader ones and then convert the other ones in the follower, so that you always have an application working, and even when this happens. A very common scenario is data locality. And let's imagine we have this data center, which we call the writer, because all the writes happen here. We have 3 indexes here that we write, and then they are replicated into other regions, maybe the US, Brazil, Spain. They are all replicated there, but these are read-only. This means you can have dashboards here or queries in these regions, which are going to be very fast because they query local data. They don't need to go through the network to make a query. They have all the information here, and this information is just a replica from wherever you have from the writer data center. This is ideal for static data because these replication mechanisms, sometimes there can be some delay. Imagine this communication gets broken for whatever reason for seconds, minutes, then the information here is accurate, but the one here is not accurate yet. It will be, at some point, it will be accurate, but it may not be accurate in real time. It will be available consistent, eventually consistent, sorry. So it's ideal for data that doesn't change very much or where you don't really need that real time. Another example, another scenario, which is actually the opposite, is where you have one centralized reporting data center or head cluster. So imagine here we are writing locally. So this region, this is very typical for logs, for example. The US region, all the applications are writing all the logs to this index, which gets replicated to a headquarter. The same in Brazil. This application gets writes everything into this index. In Spain, it writes everything to this index. But then all the information gets replicated to the main headquarters. And from here, you can have dashboards and queries that can make queries on all the data from all the different indices. And they are very fast because they are local. And all the information is just replicated read-only from the main indices. And also, there can be situations in which everything is combined, and it really depends on your scenario. This is one example similar to the previous one, in which each region is written locally so that all the information is then replicated to a central headquarters that is able to read everything but not write. But for example, we can allow this cluster here to also search in the other 2 using cross-cluster search. So it depends to the different needs on every situation. So back to our example, let me show you how this will work. So remember we had this index with restaurants in Spain, right? Which has one restaurant, Chuca Ramen. Then we have this index with restaurants in Brazil, which has the Camarero. And we did the cross-cluster search cluster, another cluster which was able to search in both these two. Now we're going to do a cross-cluster replication cluster. This one is going to be replicating the information from the other two, okay? So this one, I also configured previously the remote clusters to avoid copying the IPs. So I already have here the Restaurants Brazil remote cluster and the Restaurants Spain remote cluster. So I can go here to cross-cluster replication. Well, I'm going to show you first. I don't have any index yet created yet here. If I just search for the indices in this cluster, it's empty. So it's an empty one. I only have the remotes configured. You can see I have both remotes configured, but nothing else. So I'm going to configure cross-cluster replication. So this is very simple. This works at an index level. So I'm going to say, I'm going to replicate the index called Restaurants Brazil from the Restaurants Brazil cluster. So I'm going to say the remote cluster is Restaurants Brazil. The index there that I want to replicate is Restaurants Brazil. And now I'm going to have a replica here. I'm going to call it Restaurants Brazil replica, for example. So I'm going to create that. There are a lot of settings for this. It's all documented. There are many different configuration options for this thing. And I'm going to do the same for Spain. So I'm going to say I want to have to replicate an index from Spain. The index is called Restaurants Spain. And I'm going to replicate this into one here, which is called Restaurants Spain replica. Create. So this is already replicating all the information. There's only one index. It's going to be very simple, but that's already working. That's all you need. So now if we check the indices I have here, I already have these two indices, Restaurants Spain replica and Restaurants Brazil replica, which contain the information from the others. So if I just run this query, for example, here, I can run a query against all the indices which start with restaurants locally. This is not going through the network. This is just locally. I can obtain the one from Spain, the one from Brazil, and they are sorted by the geodistance, the location from me. And just to show you how this works. Now I can go to Brazil, and I'm going to add a second restaurant called Chicapitanga. So I'm going to add this restaurant here. Now in Brazil, I have two results. If we go to the cross-cluster replication, that must have already had time to replicate the data. So if I search here, you can see I have 3 restaurants now. And you can see these ones come from the index called Restaurants Brazil replica, which is local. So if we use cross-cluster search, it's going through the network to find the others. This one is just querying locally. So I have, in this case, I can have both mechanisms here configured since you have remote clusters. So I can use this query, which this one is using cross-cluster search. Just search in the indices in the remote clusters. This one will return the 3 results. And this one is just checking, doing the same thing, but in my local indices that I just replicated. And 3 results also. Everything here is in the same data center, so it's going to be very fast. You can probably not tell the difference, but there is a big difference in the time cross-cluster search request, the time this takes, because this needs to go through the network to every remote cluster, whereas this one is just querying results locally. So that's a different thing. Also works for deletions and everything. Let me just, in Brazil, let me delete, for example, the first restaurant, the Camarero. So if this one is deleted and we go to the cross-cluster replication and I search again, you can see I already have only 2 results. That one was deleted. I only have the Chicapitanga and Chucaromen. So that's how it works. And it also works with mappings. For example, it synchronizes changes and everything you change in that index. Okay, so that's all I wanted to show. Just to summarize, what you need may depend on your case. There are many different scenarios. Each one has different needs. So for example, just to summarize some of the biggest differences is that with cross-cluster search, you have accurate reads because you are searching to the source of truth. It goes to the network, but it goes to the only source of truth. So whatever you find is whatever is the latest information. With CCR, with cross-cluster replication, what you get is eventually consistent, because there may be some delay between when the data started being replicated until it actually finished. Another big difference is with cross-cluster search, your queries have to travel through the network, so the queries are slower. In cross-cluster replication, it's very fast because you are making queries locally, so that's much faster. Also, with cross-cluster search, your data is stored only once, and with cross-cluster replication, you're actually replicating your data, so you need to have more storage to store all this information. I will share the presentation later. I have left here some links very useful for getting started. There is a guide for CCR and for CCS, but as you saw, they are very, very simple to configure. And also, I just wanted to remember you can play with different things at demo.elastic.co. Although I think cross-cluster replication was not available the last time I checked. Also, you can try for free on Elastic Cloud. The try for free, I think there is a trial period of 15 days. However, cross-cluster replication is not available yet on Elastic Cloud. What I was showing today is a preview of something that we are already testing and will be available very soon. But it's not available at the moment as we talk. And also, feel free to connect on Slack with the Elastic community. So that's all I had. Thank you very much. And I'm very happy to answer any question that you may have, if I know the answer.
Okay.
Sorry,
Okay, people. I guess we have a glitch here. We went, Julio went offline for a little moment, right? We do have a question right now. Minchao asked this question. If you, Minchao asked, can you daisy chain in cross-cluster replication? For example, restaurant Spain replica, and restaurant Spain replica.
Oh, that's a very good point. I hadn't thought about it. I think it probably makes more sense to have two replicas of the original one. Like, you can have as many replicas as you want from one index. So if you do that, you will have additional delays. Like, every time you have a replica of a replica, you are having more delay. So it probably makes more sense to have the leader and then as many followers as you want of the same leader, instead of chaining them, just having all being followers. But I think that makes more sense.
That would be technically possible, but probably not the most efficient way.
I think it's possible because when you are, well, not really, because as I said, the leader is the only one which accepts writes. The follower is read only. So, well, yeah, I think technically, I don't know, technically it could work probably. I think I need to think about it I need to write it down. I'm not sure. I have a guess it won't work because of the read write thing. But as just said, it's probably a better idea to just have one leader and just many followers.
Makes sense. Well, let's see if there is another question. I guess not so far. I have a kind of also quite academic question. I mean, this question that was made by Minchao, as he stated, it's a more academic question. He's more curious than planning to do that. He's not planning to make a chain of replicas, one replicating another. So don't worry about that, I guess. And I do have a more abstract question as well. That is, when we use cross cluster replication, the cluster of clusters can be in it will be eventually consistent, right?
Yeah.
It's not always constant. I can get two readings done at the same moment, at the same document, and get different results. That's expected because the replication takes time. But with Elasticsearch itself, it doesn't happen, right? If I have one cluster of one Elasticsearch cluster, that cluster itself does not do that, right?
Well, I think it depends. I'm probably not the best one to talk about this one, but I think when you write into Elasticsearch, until there is a refresh, the information may not be available in all the different shards yet while it's being replicated. So you may be getting a response which still didn't have your information, your query persisted. So I think it's technically possible that you write to Elasticsearch, for example, and then you get the result and you still don't see, if you query one of the nodes, you don't have that information yet, and then in another node you do have it. So I think that's technically possible. But that also depends on the number of replicas you have, for example. So if you only have one replica, that will never happen, because then you don't need to replicate data, so it will be always go to the same. But I mean, I think it depends. Everything is configurable. So it depends on your use case. You can configure the number of shards and the number of replicas to achieve the need you have.
I see. That makes sense. I mean, I had to struggle to fight the Elasticsearch configuration from time to time, and I know that a lot of things are possible, right? Configure the number of the size of the core and so on. That's good. I think it's clear to me. Well, do we have another question? Any other question? I guess none so far. So I guess that's it, Julio.
Well, thank you very much, Adam, and everyone in Brazil.
No problem. Thank you for your openness to help us with a bit more of knowledge. I as someone who will soon need to work with Cross Cluster Replication, and I'm very glad to learn these basics that I didn't know so far. So personally, thank you. I thank you personally for my learning, and thank you for the entire community that's very glad to receive this knowledge firsthand from someone that works closer to the factory, so to say. I guess that's it for today. We are going to have more for the community. I'd like to note that we are going to have more events now in August. We are starting to prepare a continuation of the series that Marcos Prado started with 2 presentations so far, and there is probably more presentations in this sense. Soon we are going to make a survey to know what the community wants to learn about, what the community wants to discuss. So stay tuned, pay attention, because your opinion will be very helpful. Again, thank you, Julio. I hope now you can rest a bit. And see you later.
Thank you very much. See you, Adam.
Bye, people. See you next time.